Okay, so question 24, A and B. Students had to work out the initial population and the population after 5 years. So they just had to substitute in T is 0 and T is 5 for part A and part B. The positives, the students could substitute into an equation. They could work out the initial population and they could calculate the population after 5 years. The errors that occurred was often we saw students substitute T equals 1 instead of T equals 0. Also, another small, not as often, would be instead of the power of 5, they were multiplying by 5. So we really just need to make sure we're practicing the power button on the calculator. And again, which comes up quite often, is that initial means time equals 0. Just saying T equals 1 was such a shame. In part C, they then had a set of axes that were labelled with time and population, but there was no scale on it. So the kids had to draw the graph of that equation. The positive was that they did plot some of the points correctly, but what we didn't often see was a very smooth exponential curve. We often saw students plot the first one, the last point, then they just draw a straight line joining them. So that was really disappointing. So they just couldn't recognise the equation. And the other error was, again, the initial population. They sometimes started at T equals 1 and didn't recognise that T equals 0 was in the domain. So we really need to just practice equations of curves and what that graph would look like. Sometimes kids plotted every single point, or not every single point, they'd plot the 5 points, but because there was no scale, it actually didn't, it sort of went up and down and everywhere in the scale, okay, because the numbers were not very easy to manipulate. So make sure our kids can label our axes and points accurately. And again, just remembering initial means time is 0, because again, kids were drawing the graph from T equals 1. The next question was 37. We had an obtuse angle triangle and they had to find the size of angle ABC. They worked out the acute angle using sine rule was 47 degrees, and then had to realise they had to minus it from 180 to get to 133 degrees. The positives was we did actually get kids to use one of the trig rules, which was great. They did recognise an obtuse angle was greater than 90, because often if they got an answer that was less than 90, they went, oh, there's an error, it's not obtuse. But they really didn't know what to do next. So the errors that did come out was they couldn't identify the sine rule. Sometimes they'd start the sine rule, then they'd go to the cosine rule, then they'd try SOHCAHTOA, one of the other right angle triangle ratios. They'd sometimes try to use Pythagoras' theorem to find a missing side. So lots of errors because they just couldn't find this obtuse angle. They struggled with that. So some students could work out that got to the set where sine theta was 0.733, but then they couldn't calculate the acute angle. Once they found it, they didn't often work out the obtuse angle. Or if they did, they then minus the 180, minus the 47 degrees and the 28. So they used angle sum of a triangle, recognizing it wasn't obtuse. So they did something extra. They just didn't understand that all they had to do was minus it from 180. When they did use the sine rule, sometimes we just saw that incorrect manipulation of it to find that missing angle. So we really need to make sure our kids know when to use the sine rule, when to use the cosine rule, and what letters and angles go together. When they are using the sine rule, obviously, if the question tells them that they need to work out an obtuse angle, that they realise that the calculator will only give them the acute angle. I think a lot of kids struggled with this section. So they didn't know that that's what they had to do. So we need to just make sure we're practicing our kids finding obtuse angles when the calculator will give you an acute angle, but not using the angle sum of a triangle, which we actually saw some people, recognise that was acute, but just do an incorrect step after that. Also, writing the equation required to find the unknown angle when you're finding an angle is really important. They struggled with that, so we need to have them set out the equation much better. And also know the difference which trig rules you can use for right angle triangles, which ones are for non-right angle. You know, the fact that Pythagoras' theorem doesn't just work in any triangle. So we really need to make sure that that comes about. Question 40, they had a future interest table, and they had to, this question involved 2 steps. They had to find the value of the annuity at the end of the 8 years, then take that and compound it for another 2 years. So the positive was that they recognised they needed to use the table for the annuity. They could identify the numbers on the table. Sometimes they circled them, sometimes they highlighted them, but they recognised which number they needed in the table, which is great. However, errors that occurred was, of course, they would combine the 2 sections and then therefore get the incorrect values, making sure they keep to the same row or column. And they just didn't recognise it was 2 distinct steps. They didn't recognise the table was for the first part for the annuity and then the compound interest. Often they would use the table twice, so they used the table once, then for the next further 2 years, they used that value and used the table again. So that was a common error. We saw a lot of people not use compound interest formula. So they just would either use simple interest, or they, as I said, most common would be to use that table again. So we really need to practice reading these tables and also practice compound interest. They didn't have to do anything to the compound interest formula because it was all annual, which was great. Also, even though our kids don't need to change these percentages to decimals, but if they choose to, as soon as they do that, we need to make sure they are writing them as a correct decimal. There was a lot of percentages where they just wrote them out as a decimal and just did not get them right with their decimal points. So really, if they're going to convert them to decimals, make sure they are correct. So practice that. They need to know what the difference between an annuity and compound interest is, because obviously the table was for an annuity and the compound interest is something totally different. When they look at their solution, when we are talking about money, they really need to look at how reasonable that solution is. Question 41 had a lot of things for them to do. So they had the first table where they had to identify on the graph where the 2 females were. Then from that work out the standard deviation and then the mean. Then use the second table to work out the mean and standard deviation of the males. Then work out that the selected male was 84% taller. So that was 1 standard deviation above the mean. So there was lots of information there, 4 marks, 2 tables, and what did our kids do well? So our kids could label a correct height for one of the females. They struggled getting them both correct. They also struggled, they could calculate the height for females from an incorrect standard deviation. So often they would get that standard deviation incorrect, which is the very next step. But from that, the rest of it could follow. So that was really good. Some students could really see that 84% represented 1 standard deviation above the mean, which is good. So they recognised that. So they were the positives. The errors that occurred was because they didn't label both the heights for the females on the curve. That led to lots of errors. The standard deviation for females caused a lot of issues. Even if they had them labelled correctly or incorrectly, to work out the standard deviation, because it was a decimal, they really struggled with it. They, if it was a whole number, I think, we get them to draw it and they could actually see by observation what the standard deviation is. But this time they had to divide by 3 and they really struggled with that. Then they also struggled with that second table, because in the second table, they actually had to look at that notation. And when they saw that the male mean was 1.05 mu, a lot of them thought that the mu for the males was 1.05, not that it was 1.05 times the mean of the females. So that notation sort of threw them. What we need to do is get our kids to, practice using that normal curve, practice that Z-score questions with fractional combinations. They struggled with the percentages that were given, that 97.5%. They struggled with the 16% and the 84%. So we need to look at all those percentages. Also, our standard deviations. We are so often doing questions with whole numbers, making sure that they are not finding the standard deviation just by observation, but actually by a division, working out how many spaces to divide by, and that they're decimals, so that they struggled with the fact that it was a decimal. We really need to calculate standard deviation from the points marked on the normal curve, okay, not just by. So just like in this question where they had to divide by 3, not by observation, as I said. The notation, as I said earlier, the same thing. Look at that notation that it represents 1.05 times mu. In this question, there was so much working that they had to do, a lot of sections. So we need to get our kids to show their work clearly, concisely, so that we can follow it. Also, once they got their solution, just look at how reasonable that solution is for the height of a male. So that was the section for standard 2. So in standard 1, we have question 18. Question 18 had 4 parts. So in part A, they had to plot the last 4 points. Then in part B, they had to add a line of best fit. So that's the solution there. Positives was most kids could plot the 4 points quite well. They understood that a line of best fit lies equal distance between all points. Their error was probably about being a bit more accurate with the line of best fit and not joining dot to dot. We did see a lot of people just joining dot to dot because they thought that was how you're going to get a line of best fit, including every single point, rather than a line that represents all the points. So making sure our kids bring a ruler to the exam and being able and recognising a line of best fit is a single line, no dot to dot. In part C, they had to do 3 things and it was given 3 marks. They had to say whether it was linear or non-linear. They had to give us the direction and the strength. Then in part D, they had to find the mean of the last of 3 groups of size 7. Positives was that they did choose the association was strong. They could tell us for strength, it was strong. It was an error that did come up that was quite surprising was it did say clearly choose if it was linear or non-linear. We had a lot of people that didn't choose one. They all didn't write a solution for direction or strength. So, they would maybe just answer one of the 3 things, but that question clearly had 3 marks awarded for it. In part D, where they had to find the mean, they did look at the 3 numbers, add them and divide by 3, but they did not calculate the total first before dividing by 3, so therefore it gave an incorrect answer. They didn't put any brackets or use their fraction button on the calculator. So we need to make sure that our kids are reading the questions carefully. If the question says choose a solution when given 2 options, actually choose one because you've at least got 50-50 chance of getting one correct, and make sure they understand all the association of points on a scatter plot. So linear, non-linear, positive, negative for direction, weak, moderate, strong for strength. Look at the value of the marks in the question because that gives away how many things we should be doing for that question. Also, when we're finding the mean, actually know the difference between mean and median. We did see some people put in 13 just because it was the middle score when it arranged in the order that they were, rather than they didn't rearrange them either. Also, BODMAS, when calculating the mean of a set of scores, or when they use their calculator, if they use their fraction button, so much easier, it would have worked it out for them really nicely. Question 28 has two parts. So in part A, they had to find the missing side, x, y. So they had to use the cosine rule and work out the missing side. So they did well at recognizing they had to use a trigonometric equation. Sometimes it was the wrong one, especially because the hypotenuse was along at the base of the bottom of the diagram. So they looked at it and thought it wasn't the hypotenuse. The use of 30 degrees as a side length, and the use of Pythagoras' theorem. So we often saw Pythagoras' theorem because they thought, they just went, okay, 30 degrees, put that as a side length, and now we've got three numbers on our triangle. So we really need to make sure our kids know that reference sheet really well, where they actually can locate which trig ratio, and just labeling each of the sides carefully. They need to know that the side opposite the right angle, the hypotenuse, is always the longer side, because if they didn't recognise that, they then got an incorrect solution. Then when they tried to substitute it in, they'd get an error on their calculator. So writing the equation required for the unknown side was really important. So labeling here in this triangle, because of the orientation, was one of the downfalls, where they didn't recognise that the hypotenuse was XY. So there was a lot of errors that came from that. In part B of the question, they then had to work out the area of that triangle XYZ. So they had to work out the other missing side, YZ, with another trig equation. Then they had to use those two solutions to work out area of a triangle, half the base times the height. Worth 3 marks, so worth a lot of marks. Positive was that they could use the area of a triangle formula. Okay, we've been doing it for a long time. The error that did come out quite often was the fact that they used the area of a trapezium. Probably in the reference sheet, when they're trying to find the area, they look at that one, they had an extra few letters or extra few terms. They used that formula for some reason. The assumption that, as I said before, the assumption that the bottom of the diagram is the base, they didn't look at the right angle and identify the sides required again. Because of that, they actually just missed out on calculating YZ. They didn't even think that they needed to. Okay, so recognizing that for a right angle triangle, you generally will require Pythagoras' theorem or trigs, which they overall did. Knowing that the area of a triangle can be found by using half base times height, okay, overall, which was done quite well. Some kids did use the formula half AB sine C. For those kids, it actually worked out much easier if they knew that formula, not that it is necessary, obviously, in this course. Again, the side that appears on the bottom in the diagram, not necessarily the base of the triangle. So when we're practicing these questions, we need to really make sure we are practicing with different orientations of our triangles, so that they just don't expect the base to be at the bottom of the triangle. Okay, thank you.